Hello, Math 2. This is Mrs. Bricky, and the video is for Unit 8, Lesson 5, and this is going to be Part B where we are comparing functions. So here's our first example. We're going to try to compare a graph to an equation. So this graph represents the height of a baseball in feet as a function of time in the seconds after it was hit by player A. So player A. And then we have an equation right here that represents the height in feet of the ball t seconds after it was hit by player B. So without graphing the function g for player B, we want to explain and figure out the answer to these questions. So we have 3 questions that we want to answer. The first one is, which player's baseball stayed in flight longer? So if we're thinking about how long it stays in flight, we're looking for, its flight starts at time 0. We are looking for what time does that ball hit the ground. So we're looking for the x-intercept. So for player A, we are just going to estimate that from the graph. We don't have the equation or anything, so the only thing we know is this, picture of the graph. So for player A, it looks like that it's hitting at approximately 5.1 seconds. So for player B, we have the factored form of the equation. So the 2 x-intercepts come from each factor. So our 2 factors are negative 16t minus 1 and t minus 4. And each of those gives us one of our y-intercepts. So if I set negative 16t minus 1 equal to 0, t equals negative 1 over 16, and that's a negative number, so in the context, this number doesn't really make sense. The parabola for player B probably looks similar to player A's, so that negative intercept that we found is, it's like right here, but in context, it's meaningless. All right, so then let's see what the other one was. If t minus 4 equals 0, that means t equals 4. So it looks like for player B, it's going to be in the air for 4 seconds. So our question was, which baseball stayed in flight longer, and it would be player A's baseball. Okay, so let's think about question B. So I've got the graph and the equation up at the top of the screen still. Which player's baseball reached a greater maximum height? So again, for player A, we have to sort of estimate that from the graph. And if I had to estimate it, I don't know, I'd probably say 105 or maybe 108. I don't know. I'm going to go with 105. 105 feet high. All right, well, for player B, we have the 2 intercepts that we just calculated a minute ago. We had the x-intercept negative 1/16 and 4. So to find the axis of symmetry, it's those 2 added together divided by 2. It's basically their average. Whoops. So for player B, the x value of the vertex is going to be negative 1/16 plus 4, all divided by 2. And so that gives us an x value of 1.96 6.875 seconds. We're looking for the height of the ball, so we need to sub that value into the function. So that's -16 times by that t value minus 1, and then this time that we just calculated, 6.875 minus 4. So I'm going to calculate that in my calculator. -16 and that gives me 66.02 feet if I round to the nearest hundredth. So if we were looking for the greater max, that would also be player A's ball. Okay, and then the last question is, how can you find the height at which each ball was hit? Well, if you're looking for the height at which the ball was hit, you're looking for this y-intercept where its flight started. That's a little bit tricky to estimate from the graph. For player A, we would maybe estimate 4 or 5 feet. For player B, we would sub 0 into our equation because we're looking for the y-intercept. So for player B, we would have g of 0 is equal to -16 times by 0 minus 1 times 0 minus 4. And that gives us 4 feet. So they were hit from approximately the same height, I would say, of around 4 feet. It's really impossible on that graph to get any closer estimate. Okay, here is our last example. Which quadratic function has the greatest maximum value? So I've got 3 functions. I have function f, which is in the form of an equation, function g, which is in the form of a table, and function h, which is in the form of a graph. So we're looking for which one of these has the greatest max. Let's start with function h because it is the one that we already have a visual representation for. So if we're looking for its maximum value, that would be a maximum of 12. It reaches a height of 12. And we'll just go backwards here since we have g of x as a table. In g of x, you can see that the function is going up. It goes from 4 to 7, then it goes from 7 to 8, and then it turns back around. So this is our vertex. So, and if it helps you can make a little sketch. -1, 4, 0, 7, 1, 8, 2, 7. So you can see it's a parabola that's opening downward. So the max would be the 8. It's the y value of the vertex. Okay, our last function is in the form of an equation, and that is definitely the one that is going to be the most work. We're looking for a y value of the vertex. So we're going to use the axis of symmetry to get the x value. So it's negative b over 2a. So our b value is -6 and our a value is -1. And that gives us -3 as our axis of symmetry. And then once you know your axis of symmetry, if you're looking for the y value, you have to plug that y value or sub that y value into the equation. So we have a negative in our function. We're subbing in a -3. And you can calculate that, in your head if you like to do some mental math, or you can calculate it in your calculator. F of -3 is equal to 10. So F has a maximum of 10. So then if we are being asked which of those functions has the greatest max, the answer would be h of x has the greatest max. All right, that's it for this Part B video. Let me or your teacher know if you have any questions. Thanks.